Hello and welcome back everyone. In today's video, we are going to learn about how to create special yet useful arrays using NumPy library in Python. So let's get started. The first function that I am going to show you is arange function, which generates a range of values between two given points. So let's call our array as range array, and after that I will type np.arange, where arange is an inbuilt function which accepts 2 points. So let's suppose that I want to generate an array consisting of values between 0 to 10. So my starting point is 0, ending point is 10, and close the bracket. In the next line, simply print the name of the array, which is range array, and run the cell. And here I get to see an array consisting of all the values in the range 0 to 9. As you can see, these are evenly spaced. Now we can also add a third parameter, which is known as step. So let's suppose I only want to display even numbers inside my array. So I will provide here the third parameter as 2 and rerun the cell. So here I get to see an array consisting of only even numbers between 0 to 10. In the same way, if I want to generate an array consisting of only odd values in this range, then I will change the starting point from 0 to 1 and rerun the cell. And this time I have got an array consisting only of odd numbers. The next function is a similar one and it's called linspace. So let's suppose I am creating an array called linArray equal to np.linspace, and this function is an inbuilt function which generates a sequence of numbers that are evenly spaced between two given points. So once again I will have to supply a starting point and a stopping point. So let's say I supply 0, 1. That means I am generating a range of numbers between 0 and 1. And when I print this linArray and run the cell, I get to see a range of linearly spaced values between two given points, which are 0 and 1. And as you can see, 0 and 1 are both included in this range. Once again, you can supply a third parameter which specifies how many values exactly you want within your array. Let's suppose I only want 5 values. So I'll run the cell again, and this time I have got linearly spaced values, and these are 5 in number. Once again 0 and 1 are included, but other than that we have 3 more values. Let's move on. The next important function that I want to show you is zeros function, which is used to create an array of zeros. So let's suppose my array name is 0 array, and here I will type np.zeros, and inside the parenthesis I will mention how many zeros I want within this array. Let's suppose I want 5 zeros, and then I will print 0 array, just pass the name of the array and run the cell, and in the output we have got an array consisting only of zeros. Similarly, if you want, you can create an array consisting of only ones. So I'm just copying this and pasting the code over here. I'll change the name from 0 array to ones array, and here also I will change it to ones, and instead of zeros function I will use ones function. Let's change the number of values that I want in my array to 4. Let's run the cell, and we have got an array consisting of 4 ones. We can also perform broadcasting on these arrays. Let's suppose I want to create an array of tens. So let's say tens array is equal to np.ones, and then we will supply how many values we want within this array. Let's suppose I want 3 values. I will multiply it with 10, and then I will print 10 array, and after that I will run the cell, and I get to see an array consisting of 3 tens. So this is how you can perform broadcasting. NumPy arrays also support creation of identity matrix. So let's suppose I want to create an identity matrix, then I will use I function, and I will pass here 3, and when I'll run the cell, you get to see 3 ones on the diagonal. In the end, I want to discuss about generation of random numbers. So let's suppose I want to generate a random floating point value, then I will type here np.random. Here random is a module of NP library, and I will then type .rand, put a set of parentheses, and then I will run the cell, and here I get a random floating point value. If I rerun the cell, so every time you are running the cell, you will get a new value. If I want, I can also specify exactly how many values I want. Let's suppose I want 3 random numbers, and then I'll run the cell. So I get to see here 3 floating point values. All of these are random values. So every time I'm running the cell, I will get a different set of values. If you want to generate a whole number, then use randint. Let me show you. So we will type here np.random.randint, and after that you have to supply the range within which you want to generate a random number. Random numbers are mostly useful in dice operations. So let's suppose I want to generate any random number between 1 to 6. Let's run the cell. So I have got 4. Let's rerun, and this time again I have got 4. Right. If I want to add another parameter, let's say I want to generate 3 random values, and these all will be whole numbers. I'll run the cell here, and this time I have got 3, 5, 3. These are a set of 3 random integers. Once again I'll run this, and this time I have got 3, 2, 3. So this is how we generate random numbers using NumPy library. If you found this video helpful, then don't forget to share it with your friends. Also, like and comment on this video and subscribe my channel Programming Horizons for more videos like this.